This is the screencast for section 3.5, example 4. All right, we got some more derivatives of basic trig functions that you need to memorize immediately. The derivative of tangent is secant squared. The derivative of secant is secant tangent. The derivative of cotangent is negative cosecant squared x, and the derivative of cosecant x is negative cosecant x cotangent x. Hey, quick question. What's the derivative of cosine? What's the derivative of cotangent? What's the derivative of cosecant? Oh, did you notice all the cos are negative? All the non-cos are positive. All right, there's my little hint. Example 4, finding the tangent and normal lines now that we know these new derivative of trig functions. Find the equations for the lines that are tangent and normal to the graph of this at x equals 2, support graphically. Okay, here we go. So if I need a tangent line, I need a point and a slope. So the point is going to be at x equals 2, so that's going to be 2 comma f of 2, which in this case is 2 comma, let's see, tangent of 2 over 2. Now as far as the slope is concerned, I need to find the derivative. F prime of x, that is going to involve the quotient rule, so I'll leave the denominator alone, multiplied by the derivative of the numerator, so that's secant squared. Minus, now leave the numerator alone, multiplied by the derivative of the denominator, which is just 1, and then all over denominator squared. So f prime of 2 is, let's see, 2 secant squared of 2 minus the tangent of 2 all over 4. Now I know what you're thinking. This is really messy. Can I just put this in my calculator and type out a decimal? The answer would be no. So instead what we're going to do is write out your slope as this expression. Now you already have f prime of 2 stating that it's this, so now you can use a shortcut. Let me show you what I mean. My tangent line is going to be y minus f of 2, which I've already said over here is tangent of 2 over 2, equals my slope, so that's going to be f prime of 2, which I've already defined on this page, so I don't have to worry about that, times x minus, and then the x coordinate's easy, that's going to be 2. Now the normal line is going to be all the same, y minus f of 2 equals the slope of the normal line is going to be the reciprocal, so 1 over f prime of 2, and the opposite of it, so negative. And that's all I need. Now to check it in my calculator, unfortunately there's not that great of a shortcut. What I did was I graphed the whole expression for the tangent line, and since the only thing that changed was the slope, I just assumed I would get the slope right if it were opposite and reciprocal. So now try problem number 23. Says find equations for the lines that are tangent and normal to the graph of y equals x squared sine of x at x equals 3. Now, I guess we didn't throw any of those new trig derivatives at you, but again, make sure you got those memorized. Alright, so our function is y equals x squared sine of x. We need a point. The point is going to be 3 comma f of 3, which in this case is going to be, let's see, 9 sine of 3. Now to find the slope, I need to take the derivative, which is going to involve product rule. So the derivative of x squared is 2x, and then we'll multiply by sine of x, and then add, leave x squared alone, multiply by the derivative of sine, which is cosine of x. Y prime of 3 is 2 times 3, 6 sine of 3 plus 9 cosine of 3. So now I've got a point and I've got a slope of my tangent line. So my tangent line can be y minus the y coordinate, which we said was going to be 9 sine of 3, equals the slope, so 6 sine of 3 plus 9 cosine of 3, times x minus the x coordinate, which is just 3. Then the normal line will be using all the same points, so y minus 9 sine of 3 equals, and I'm just using the opposite and reciprocal, so negative 1 over 6 sine of 3 plus 9 cosine of 3, and then times x minus 3, same x coordinate.